Okay, consider the equation y equals 2x minus 25. We know we could make a table of values for this, and we could draw it on graph paper and see what it looks like. But calculators can do this stuff too. Let's see how they handle it. Use a graphing calculator to sketch the graph on the grid provided. Write a suitable window. So, if you had a calculator that looked something like this, you can press the y equals button to get into your graphing page, and we can copy in this expression, 2y equals 2x minus 25. Here it already says y equals, so you put 2, this is your x button, minus 25. And when you're happy with that, you press graph. Now, this isn't going to go very well when I press graph, but we'll just walk into the trap and see what happens. Graph. Here's the line. And the problem is your calculator by default uses a window setting, the coordinates of this axis, that looks like this. It goes from minus 10 to 10 in both directions. The interesting stuff on this line seems to be happening off to the right, much higher than 10. It's happening to the right and down. So let's look at this window some more. Our minimum x is minus 10. That's off to the left. That isn't what concerns us. Our line is over further to the right than this, more than 10. Let's push this over some more. We'll make our maximum 20. That means we're extending the window off to the right. We also want to extend it down because we saw that our line was to the right and down from where we were looking. So let's make this minimum minus 20, and we'll see what that does for us. Better. Still not great that we can't see this section of the line. How do you think we fix that? This part of the line is down at the bottom of the window, so we need to push the bottom of the window even lower. The bottom is our y minimum. If we make it, let's go minus 30 and see what we get. That's more like it. So, thing to remember here, please, if you want to see more on the right of your window, you need to change x max. If you need to move the left of your window, you're changing x min. That's the minimum value of x. If you want to change the top of your window, that's y max. That's the highest value of y. And if you want to move the bottom of your window, that's y min. So here we changed x max to move our view to the right. We changed y min to move our view down. And the question they're asking, write a suitable window. So tell us what window settings you ended up using. We went from minus 10 to 20, scale of 1, and minus 30 up to 10 with a scale of 1. The scale is how often it puts tick marks here on the axis. I never change it. There's not much point. So don't worry about the scales too much. They're normally at 1, and you can just leave them there. But they want to hear that we went from minus 10 to 20. Minus 10 up to 20 in steps of 1, and our y went from minus 30 up to 10, again in steps of 1. Use a graphing calculator to determine the value of y when x is 4.5. Two ways you can do this, a kind of fast, sloppy way, and then the good way. The fast, sloppy way is you press trace, and you get a little bug here that's sitting on your line, and it tells you what the coordinates of that bug are. You can move the bug around by pressing the arrow keys. You can watch the coordinates change as you do that. Using this, we can go over to 4.5. Watch the x's here as I head towards 4.5. And, well, here's the bad news about the bug. It isn't good at stopping precisely where you want it to. Here the only choices it's giving me are 4.36, 4.68, neither of which is all that close. And my y is, I don't know, is it minus 16? Is it minus 15.6? It's somewhere in the minus 16 neighborhood, but I'm not exactly sure. So using trace, the best I can do here is say that y is minus 16-ish. If you just need a quick and dirty answer, that's fine, but sometimes we need to do a better job than that the calculator has another way of doing points, and it's in the calc menu here. This is printed in yellow, so you go yellow key, calc, and the very first option is value. Pick that. It says, okay, tell me an x. I want 4.5, please. If you do that, the calculator absolutely nails it. It says x is exactly 4.5 as you requested, and here's the y that goes with it. Now here, I lucked out and picked minus 16 using the trace. Normally, you won't have this much luck using the trace option. It's only for if you just need a really rough answer, and value is the way to go, because it can give you exact answers. When x is 4.5, the value is minus 16. Algebraically verify it, they say. Well, if we know x is 4.5, we don't really need the calculator. We can do this. This equation says y is 2x minus 25. So our y value is 2 times, they said x is 4.5, minus 25. 2 times 4.5 is 9, minus 25. And lo and behold, that does give us minus 16. So we can do this as well as the calculator can, we just aren't quite as fast. Use a graphing calculator to determine the value of x when y is minus 6.4. The difference here is they aren't giving us an x value this time, they're giving us a y value. And that makes things a little complicated. If y is supposed to be minus 6.4, we'll try trace and see how we do. Yeah, look at this. X can be either, or sorry, y can be either minus 6.7 or minus 6.0. Not very close to 6.4 either way, so we're going to get a lousy answer here. You can see it's 9 point something or other either way. So using trace, pretty lame answer. We get 9.2, 9.3. I wouldn't even know what to pick for that value. It's 9 point something. If you want to get it exactly, this is a little more involved. You have to go back to the graphing menu. And we're going to put in another line. They said they want y to be minus 6.4. Yeah, just making sure. Okay, they want minus 6.4, so we'll put in a line at minus 6.4 graph. Here's minus 6.4. Exactly here is the point we want to locate. Trace doesn't know how to do it. It can't land on minus 6.4 no matter how much hopping around you do. But there's another function in the calculator that is good at finding crossing points where two graphs intersect like this. You go to second, trace again, and there it is. It's called intersection. That's where two lines cross each other. You select that. It's going to ask you what your first curve and second curve are, and for that, generally, you can just hit enter twice. It's saying, is this your first curve? Yeah, it is. Enter. Is this the second curve? Yes, it is. Hit enter. Then it asks you if you want to guess where that coordinate is, and you don't really need to do that either. Just hit enter yet again. And after a fraction of a second, it says, if you're at minus 6.4, x must be 9.3. So, to summarize, to do that, you go second trace, intersect, and if you've only got two curves in the calculator, you just go enter, 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 and it will find the nearest intersection point to where the bug was. In this case, 9.3. Algebraically verify. Okay, we can do that. We know our equation is y equals 2x minus 25. If y is minus 6.4, we get this. Minus 6.4 equals 2x minus 25. We have to solve this for x, so add 25 to each side. Those cancel out. We get 25 minus 6.4 is 18.6 equals 2x. Divide both sides by 2 to get x by itself, and look at that. x is 9.3.